Fantastic. All right, boys and girls nation, welcome to day three. Yes, and this one is all about a chance to react. Yes, we are going to look at chemical reactions. Now, before we start with anything, boys and girls, if you've joined us for the previous 2 days, welcome back. For those that are new, I've got scientist Sarah. You might have seen on our social media accounts.
And we're also joined by our mad scientist, Chris, who is our in-house scientist at Empiribox.
And there we go. Now, boys and girls, ladies and gentlemen, today we are going to look at chemical reactions. Yes, we're going to look at chemical reactions. We're going to specifically focus on evidence. How do we know a chemical reaction has taken place? Now, for our learning objective, we know that we are going to explain that chemical reaction or these changes creates a new material, a new substance, and that these changes are usually irreversible. We're also going to focus on your investigation, which you're going to do at school or at home. You are going to be playing and looking at the reaction between bicarbonate soda and acid. And that's all the things that we're going to do. Yes, so we've got a few fun-filled things planned for today. Now, the first one we're going to focus on is this little black bottle right in the front. So, boys and girls, ladies and gentlemen, I want you to make sure that you're using your observation, because I want to know, what do you see, what do you notice will happen to this bottle? So just pay very close attention and see what happens. Now, I've just got my little black bottle here and my old cork. What happens if I just remove this cork? What happens? What do you see? What happens? Just look very closely. What do you guys can see? I don't know if you guys can see it that clearly. Can you guys see any smoke coming out of that at all? I'm not sure if I need to do that a bit closer. Yes, you can see smoke. I'm going to bring it a little bit closer to the screen so you guys can see all that wonderful smoke that's coming out of here. Now, it's not bellowing out like I wanted to, but it's all right. So how do I know a chemical reaction is taking place? How do I know a chemical reaction takes place? What was that key little factor there that a chemical reaction has taken place? That is all that smoke. That's what I can see there. Now, I can repeat this experiment again, but this time I'm going to show it in a clear bottle so it becomes a little bit easier to see. Now, yes, first, because two compounds are reacting to make smoke. You're absolutely correct. Now, what I've got here is something known as hydrogen peroxide. It's the same chemical that hairdressers use to make your hair go blonde. So I'm going to fill that in to my bottle right here. So I'm going to put all of the chemical inside there. And then the second chemical I'm going to use is something called manganese oxide. And I've got a little pocket here that I'm going to do. So, boys and girls, if I'm just going to quickly pop that in there, and you're going to see what happens if I make it react with each other. So if I just shake that in, you can clearly see, and there we go. This is a much clearer one that you can see. It just starts to produce a lot of smoke, and it goes almost everywhere. But there's a few other things that you might have noticed. Not just the smoke bellowing out all the way, as you can see quite nicely, like a genie in a bottle. That's a much nicer one, isn't it? This is a much nicer one that you can see here. But do you guys also see the bubbling going on at the bottom there? So not only do you see the smoke going everywhere, so I could even go all the smoke, but this is actually vapor. And you can also see a wonderful color change. Now, I know that in these two, a chemical reaction has taken place. A change has occurred. That means something new was created, a new substance. So that's going to be my first point of call. So I know that smoke or vapor is a key indication that something new was created. All right, Sarah, are you going to show them the next one?
Absolutely. Okay, so what Chris has just talked about there, we can smoke everywhere. What Chris has just talked about there is that we can tell a reaction has taken place because we're looking for one of those kind of telltale signs.
And there we go.
It's going all over the place, look. We can see what, wow. Science never works when you want it to, does it? Honestly.
No.
So we can look at one of those telltale signs that tell us that two chemicals have reacted together to produce something different, so a product, okay? And we obviously saw, I do need to put my safety goggles on, thank you, I have not forgotten. So what we're going to look at the, here is an example of chemiluminescence. Now that's a really, really big word, isn't it? But chemi because we've got chemicals involved, and luminescence because it's giving off something. And I want you to have a look at what happens in a minute. Okay, so I'll pop my goggles on. Thank you, Rose, for the reminder there. Oh, I tell you what though, we do need to do a shout out to the Bat School. Hi, Bat School. Your school governor Joe wanted us to say hello to you. Apparently you guys, and I can see your waving, yay! So apparently you guys have been having great fun with the experiment so far, so that's fantastic. If anybody else wants a shout out, then get in touch here. So what Chris has done here then is he has put into the bottle. So this is my chemiluminescence mixture. So Chris, as I said, is our mad scientist who makes sure that all the chemicals are pre-prepared. So when you get your equipment from Empiribox, you don't have to worry about mixing things together. It all comes in these ready done bottles for you. So I'm going to take my chemiluminescence mixture here, along with a beaker which has got water in it and just 1 ml of hydrogen peroxide here. So just give that a little bit of a stir to make sure that it's all fully through. Do you want to hit the light?
Yeah, we'll hit the lights.
Okay, so hopefully when we put these two chemicals together in the top, you should see something happen as the chemicals react.
Is it?
Oh.
Is it not shining through that clearly? Hold on. No, that's all right. As you know, boys and girls, ladies and gentlemen, in science, it doesn't always go the way you want it to. It's not a problem. Luckily, we've got a reset very quickly.
We've already had a couple of goes at the little experiments this morning to make sure that they work properly for you, but there's always something that doesn't quite work. Yesterday, my bottle pop rocket was a very interesting one. I hope that you guys had a bit more success with your pop rockets. And yesterday, the weather was a little bit better for doing this in your classroom, wasn't it?
It's just
for doing it outside.
Yeah, it's no problem. I'm just going to give you new water. Yeah.
Okay, so that's my first chemical ready. So this is my chemiluminescence. So all mixed and good to go.
Yeah, I'm just going to give you some.
So we're just mixing our water with the hydrogen peroxide here.
And then I'm just going to pour it. Just a good bit of mix.
Okay.
Let's see if that now works.
All right, come on, fingers crossed this time.
Now, boys and girls, what you should see.
Oh, somebody's had great fun making the pop rockets.
So, boys and girls, what you should see is actually a change in, light is produced. So, light is produced. So, if I put these two together, there we go. That's a bit better. Pour a little bit more. I don't know if you guys can see how blue it goes. You can stop, Sarah. Stop.
Oh, look,
Yeah.
I'm here.
No, it's all right. It's not the end of the world. We've got paper towels for that. So, boys and girls, I don't know if you can see, but we've actually got a little bit of a glow going on into that substance. That basically tells me that these two chemicals have reacted with each other. And one of the key things that the chemical reactions have taken place is that light was produced. So we know that light was produced, and that's another key. So the first one we saw smoke, vapor. The second one we saw here, we basically see that light was produced. All right, just quickly switching off the lights. All right, Sarah.
Right, sorry.
No, that's all right. Don't worry.
Just having a little bit of a clear up, make sure safety first. You know, we don't want spills, etc., on the table for our next demonstration, which Chris is going to do for you. Get out of the way.
Yeah.
There we go.
All right, now, boys and girls, another thing that tells us about a chemical reaction is when something occurs. But this one we're going to focus on is all about color change. Now, if you look at this bottle of mine, if you can see, the substance I've got in here is quite clear, but I don't like that at all. So watch what happens if I just shake it. Look very closely. Look, it changes color. But if you look very carefully,
whoa,
it goes back to clear. Now look again. I'll show it again, boys and girls. I'll shake. It goes blue. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, boom. It goes clear. Now, boys and girls, what is going on here? Oh, one of the most amazing things. Now, the two previous chemical reactions we looked at are called irreversible changes. Now, I know that it is irreversible because I cannot get my substances back. This one on the other side, this one is considered a reversible reaction because you can see it changes color to one side, but then it changes back to clear. So it goes back to its original form. And what I've got in here is some very easy things. The first thing I'll put in is hydrogen peroxide pellets. So it's kind of type like a bleach. The second thing that I put in is a bit of sugar. Now, I know we all like our sugar. Sugar is our energy. I've got water, and then I've got something called methylene blue to give it that bit of color change. And as I shake it, it actually bonds with the oxygen inside the bottle, and that's why you can see the blue. But then the bleach comes in and says to the oxygen, get out, and it changes back immediately. Now, this one is called our blue clock or blue bottle reaction. And this one, as I said before, is reversible. So there are so many different things out there that we know a chemical reaction takes place. You've seen with us smoke, you've seen that light is produced, and you can see a change in color. But you also have numerous different ways of that something new or chemically have reacted. Like, for instance, fire is a great way. If something burns, you know a chemical reaction has taken place. If you look at sound, bubbles, all these things tell us that something new is made. Now, we are going to look at your investigation you can do at school today. And Sarah, would you mind explaining to me what all the things that they are going to do?
Absolutely. Okay, so for your science experiment today, then, you are going to have a look at the reaction between bicarbonate of soda and acid, okay? Now, we talked yesterday, didn't we? We used acid yesterday in terms of vinegar. It's exactly the same kind of thing. So the sort of things you'd put on your fish and chips, and you guys are going to have a go at that today, okay? So all you're going to need for this, then, is a pair of kitchen scales. So the sort of thing that you would normally weigh sort of ingredients when you're baking at home, maybe. You're going to need your vinegar or acid, so vinegar basically, and then your bicarbonate of soda. And we did say, didn't we, that you can very easily just get this from your local supermarket or something like that. It's the sort of thing that, again, you would use in your baking, okay? So what we want to do then is to put the two chemicals together to form a reaction to see if we can make a new product, okay? Because we have two reactants, which are our bicarbonate of soda and our acid, and then we want to make a product, okay? So react them together to make something new. So what I've done here is I've just added my vinegar into a plastic beaker there, and I'm going to pop that onto my balance. So if I then take a quantity of my bicarbonate of soda, and I'm just going to use...
to switch on your balance.
Oh, yeah, good point. So switch on your balance. And what we want to do is to mark down a starting mass there, so what it actually weighs to start off with. What we're then going to do is we're going to add a small amount of our bicarbonate of soda, and I'm measuring mine out using a teaspoon. I'm sure that you've probably got a teaspoon available to you quite handy at home. So what do you think will happen when I add the bicarbonate of soda into the vinegar? So we know, or we think we know, that a reaction might take place, and it could be one of many things, couldn't it? So we spoke about earlier, didn't we? So there's a possibility that when we add this in, we might see maybe light given off in a chemiluminescent reaction. It could, excellent, well done, Ferris, it could change colour. So we could be looking for a change of colour. Maybe the temperature would change. So it might be an idea to put a thermometer in here and see if actually the temperature does go up or down. We could be looking for bubbles or vapour or gas given off. Yeah, absolutely. The weight of Ferris is on it today. The weight could actually change, or the mass could change on the scales. And that's what we're going to have a look at today. So in your reaction then, what you'll do is pop your chemicals together so that you get a reaction, and then we are observing what takes place. Oh, my beaker is... Every single experiment I do goes wrong, doesn't it? So mine is bubbled all over the top and making a complete mess all over the table.
That's okay. It guys happen. So as you can see, what Sarah has done is she's put a little bit too much of vinegar in a cup. We would advise you to about 1/3 of your cup that you can put with vinegar. And then when you add the bicarbonate of soda, quickly look at what your total mass is, and then start a timer or a stopwatch and see what happens to the mass as time goes on. So for every minute, just quickly check and see what is your reading on your total mass. Has it increased, decreased? But don't forget, I want you to use your observation and record everything that you see. As Sarah has said, do you see bubbles? Do you see a color change? Do you see light? Do you feel heat? All these things you have to record so you know a reaction is taking place. Now, Sarah, don't forget about the skills.
Absolutely. So actually what you've just seen here, I could have evaluated this practical really nicely, couldn't I? Because one of the things that I could have looked at if I was evaluating this is maybe next time if I was to do this experiment again, I might look something like the elephant toothpaste and the reaction, absolutely. So if I could have done this again, how could I make sure that my results are more accurate and reliable? Well, actually by using less of the acid in the beaker, I'd lose less, wouldn't I, over the sides, and therefore I'd get a better reading of my balance. So that might be something that if I was to do the evaluation side of it, I might want to think about. I could also have a look at, well, what data am I actually going to capture here? So am I going to change the amount of vinegar, for example? That is one of the, what data am I going to capture? How am I going to write that down? So should I put this into a table? What measurements am I going to take? Do I draw a graph from this? Am I going to take temperature? Am I going to take mass? What am I actually going to collect from this? So we could also look at the planning side. So how would you plan out this practical? What are you going to collect from it? So what's your independent, dependent, and control variables? So as your independent variable, what's the one thing that you would change when you do this experiment each time? So I might, for example, want to change, well, I might want to have a go at changing the amount of vinegar I put in and keep the bicarbonate of soda the same each time. Or I might want to make sure that I keep the amount of vinegar the same and add different amounts of bicarbonate of soda and see if that makes a difference. So the independent variable is the thing that you are changing as the independent scientist in your own investigation. The dependent variable is the thing that we are measuring, the measurements that we're taking. So are you measuring the time it takes to bubble over the top, for example? Or are you measuring the mass on the actual balance? So lots and lots of things. Are you measuring how much it fizzes? It's completely up to you what you measure as your dependent variable. But you also want to think about what your control variables. So what do you need to make sure that you keep the same every single time so that your experiment isn't going to be changed by something that you don't want it to be? So for example, my vinegar would probably need to be the same temperature each time, wouldn't it? Because if I added a different temperature of vinegar, that could change something in my experiment. So let us know how you get on. I hope that you enjoy your investigation today.
Now, boys and girls, ladies and gentlemen, all the people that joined us today, please don't forget that on the link for this Zoom session, right above that, there is a link to the worksheet that you have for this session. In there will be a fun start activity for your students or you to do at home. You also have a step-by-step guide that tells you exactly how much volume of vinegar that you put in and how many scoops and everything that is listed down there for you. You also have the questions to the skills to help you with a bit of guidance. Boys and girls, we really do hope that you had fun today. As you can see, with chemistry, things can go wrong, things can go right, and smoke and bellow out. But please join us tomorrow for sound, making some noise. Yes! Thank you, boys and girls and everybody. And we do hope that you've got some fun in science today. Thank you so much for joining us.
Get in touch on social media, send us your information, let us know how you got on. We'd love to know how your experiment works for you and if yours is slightly more tidy than mine. Bye, guys.
Bye, guys. Bye.